in this video, let me consider one numerical on Norton's theorem. Find current through 10 ohm resistor using Norton's theorem. So in this circuit, this is the 10 ohm resistor. We need to find current through this 10 ohm resistor using Norton's theorem. As we know, in Norton's theorem, the branch in which current is finding, first we have to remove that branch. That is, this branch is connected between these two terminals. First we have to remove this 10 ohm resistor from the circuit. It will become open. We have to short it. That is, so I removed that 10 ohm resistor. Now it has become open. Now we need to short these two terminals. When we short these two terminals, current will start flowing in this short circuit. This current is known as ISC, that is short circuit current, or it is also known as Norton's current. So first we need to calculate Norton's current. So I will find this current using loop analysis. Let current through this branch is, this loop is I1. Let current through this loop is I2, and let current through this loop is, I'll take same, that is IN. So this is positive, this is negative. Now let me apply KVL to first loop, that is apply KVL to loop I1. I can write 10 is equal to voltage across this is 6I1 plus voltage across this is 1 into I1 plus I2, or I can write 6 equal to, we have 7I1 plus I2. Let me call it as equation 1. Similarly, now let me apply KVL to loop 2, that is apply KVL to loop I2. So I can write, there is no voltage source, 0 equal to voltage across 2 ohm is 2I2 plus voltage across 1 ohm is I2 plus I1, I2 plus I1. Then voltage across 3 ohm is, that is 3 I2 plus IN, I2 plus IN, or I can write 0 equal to, so here we have I1 plus 2I2 plus 1, that is 3I2 plus 3, 6I2 plus we have 3IN. Let me call it as equation 2. Now let me apply KVL to loop 3, that is apply KVL to loop IN. So here we have voltage source, but I have taken current direction opposite. So let me start from voltage source. Here it will be minus 20 is equal to, because current direction is like this, voltage across 3 ohm is 3 into IN plus I2. So let me simplify, minus 20 equal to, we have 3I2 plus 3IN. Let me call it as equation 3. Now let me solve equation 1, 2 and 3, that is solving equation 1, 2 and 3 we get. So let me use calculator. So go to the mode. In mode choose equation mode, that is 5. So here we have 3 unknowns. So choose 2. So here feed the first equation. So A is with respect to coefficient of I1, B is with respect to coefficient of I2, C is with respect to coefficient of IN. So here coefficient of A, that is 7, press equal, then coefficient of I2 is 1, equal, and coefficient of IN is 0 here, 0, and we have 10, press 10 here. So we fed the first equation values. Now let me feed the second equation. Here we have 1, 6 and 3, that is 1, 6 and 3. This side its value is 0. So similarly we have coefficient of I1 is 0, coefficient of I2 is 3, coefficient of IN is 3, and this value is minus 20. So press equal once again. So this is coefficient of x is nothing but I1. So I1 is 0.5, I2 is 6.5. So let me write I1 is equal to 0.5, I2 is 13 by 2, that is we have 6.5 amps, 1667. I3, the IN is minus 13.166. I3 is minus 13.166 amp. So after calculating Norton's current, we need to calculate Norton's resistance. So to find Norton's resistance, we need to short voltage sources. That is, we have to short this 10 volt voltage source and 20 volt voltage source, and here 10 ohm resistor should be removed so that this terminal will become open. We need to find the equivalent resistance between these two terminals. That is known as Norton's resistance. Now let me draw the equivalent circuit. So this is terminal AB. We need to find the resistance between these two terminals, that is known as Rn. So let me calculate Rn here. So here 6 and 1 are in parallel. That combination is in series with this. That combination is in parallel with this. That is Rn will be equal to these two are in parallel. That is 6 is parallel with 1. This is in series with this. That is plus 2. This entire combination is parallel with 3. That is I can write 6 into 1 divided by 6 plus 1 plus 2. This value is in parallel with 3. So calculating this, we'll get 2.857 is parallel with 3. So that I can write Rn equal to, that is 2.857 into 3 divided by this plus this, that is 5.857. So it gives 1.463 ohm. Now let me draw the Norton's equivalent circuit. So Norton's equivalent circuit is we have IN. Here we can see that IN is negative. It means that here we have shown that current IN is flowing from A to B. The value of IN is negative, means current is flowing from B to A. So let me take the current in downward direction. Its value is 13.166. This is 13.166, and parallel to this we need to connect Rn. Rn is 1.463 to this terminal. This is A, this is B. Here we need to connect the 10 ohm resistor. So now the current will divide here. Part of the current will flow here, part of the current will flow here. So I2 is current through 10 ohm resistor. Therefore I can write I2 is equal to total current. I will apply current division rule. 166 into 1.463 divided by sum of these two, that is 10 plus 1.463. Let me calculate this. I2 is equal to, so we have 13.166 into 1.463 divided by denominator is 11.463. 11.463. So it gives 1.680. 1.680 amps. So this is the current through 10 ohm resistor, and it is calculated using Norton's theorem. Thank you for watching.